So let's go ahead and practice using the empirical rule. So let's look at number 2. So number 2 says that to assume that the mean weight of 1-year-old girls in the U.S. is normally distributed with a mean of about 9.5 kilograms and a standard deviation of approximately 1.1. Without using a calculator, estimate the percentage of 1-year-old girls in the U.S. that meet the following conditions. We want to draw a sketch and shade the proper region for each problem. Before I do A, B, C, and D here, I'm actually going to just over here kind of sketch the overall distribution of this data. So I'm drawing my normal model. The mean goes in the middle, which was 9.5. And then I'm going to sketch what 1, 2, and 3 standard deviations above the mean would be, as well as 1, 2, and 3 standard deviations below. So to calculate 1 standard deviation above, I add the standard deviation 1 time. So 9.5 plus 1.1 is going to be 10.6. 10.6 is 1 standard deviation above the mean. 2 standard deviations, I'm just going to add 1.1 again. So now I will have added it twice to the mean, and I will end up with 11.7. And then to find 3 standard deviations, I do the same thing. I add it 1 more time, which would give me 12.8. And that's because I've now added it 1, 2, 3. So this is 3 standard deviations from the mean. To do below, I do the same thing. So below, I'm going to subtract 1.1 because I'm going down. I'm below the mean. So that would be 8.4. I subtract it again to find 2 standard deviations below the mean, and I'd have 7.3. And then I subtract it 1 last time, and I would end up with 6.2. I'm going to go ahead and write in the empirical rule here as well. So within 1 is 68%. Within 2 standard deviations is 95%. And then within 3 is 99.7%. So that shows me the distribution of this data with the empirical rule given. So for part A, when it asks me the probability that the value or the weight is greater than 10.6, I can go over here and say, okay, 10.6 is right here, and I'm looking for greater than. So I'm really looking for this area right here, okay? So in that case, now if I look, 10.6 marks the cutoff as 1 standard deviation above the mean, and that is where the 68% ends. So again, that's the middle 68%. So I know that there's 32% left over because 100 minus 68 is 32. So if I cut 32 in half, I end up with 16% on either side. So to be above 10.6 is going to be 16%. So 16% of all 1-year-old girls in the U.S. would be above 10.6 kilograms. For part B, it says we want to know the probability that the weight would be in between 8.4 and 10.6 kilograms. So now I'm looking for in between. So between 8.4 is right here, 10.6 is right here. So I'm looking for this area in between. Well, 8.4 is 1 standard deviation below. 10.6 is 1 standard deviation above. So I'm looking for within 1 standard deviation. So this is actually going to end up equaling 68% because 68% fall within 1 standard deviation. For part C, I'm looking for the probability that the data value is less than 6.2. So 6.2 is right here, and I'm looking that it's less than. So I'm looking for this area below. So in this particular case, 6.2 is 3 standard deviations from the mean. Because it is 3 standard deviations from the mean, I know that it's a cutoff for the 99.7% of the data. So then if I'm looking for the area below that, I know that 100 minus 99.7 is 0.3. If I cut that in half, I end up with 0.15. So this area is 0.15%. So there would be 0.15% of 1-year-old girls less than 6.2 kilograms. And then finally on D, we're looking for the probability that the data value is less than 11.7 kilograms. So 11.7 is right here. That is 2 standard deviations above the mean. And I'm looking for the probability that it's less. So I'm looking for all of this probability going this way. This one's kind of tricky. The way that I would do this, so I know that from here to my cutoff is 95%. So I know that all of this area is 95%. So this would equal 95% plus this area below it. So I need to figure out what area is below this -2 standard deviations. So I need to figure out that area that way. Well, again, because that's a 95% cutoff, if I do 100 minus 95, I'm left with 5. If I cut that in half, I get 2.5. So this would be 2.5%. So then I know that all of this area is 2.5%. So 95 plus 2.5 would be 97.5%. And that would be my final answer for part D. So D is a little tricky because we have to kind of add that whole 95% and then add on that last little bit as well. Looking at number 3, it says that the heights of 5th grade boys in the U.S. is approximately normally distributed with a mean of 143.5 and a standard deviation of about 7.1. What is the probability that a randomly chosen 5th grade boy would be taller than 157.7 centimeters? Again, the first thing I'm going to do here is I'm going to draw it out. So drawing the normal model, in the middle I have the mean. The mean is 143.5 and it has a standard deviation of 7.1. So one standard deviation above it, I would add 7.1. So I would have 150.6. 2 standard deviations above, I would add again. So we would have 157.7. And then 3 standard deviations above, and I end up with 164.8. Again, going down, I would be subtracting 7.1. So 1 standard deviation below is going to be 136.4. 2 standard deviations below, I would subtract 71 or 7.1 again, and I would end up with 129.3. And then 3 standard deviations below, and I get 122.2. Now, again, I know that 68% fall within 1 standard deviation, 95% fall within 2, and 99.7 do fall within 3. But I'm going to stop here because I'm looking for the probability that a boy would be taller than, so greater than 157.7. So that is right here. And if it's greater than, I'm looking for all of this area here. So I want to go up. And since this is 2 standard deviations above the mean, that marks the 95% cutoff. So then again, if I do 100 minus 95, I end up with 5. If I take 5 and divide it in half, I get 2.5. So above is 2.5. Again, I cut it in half because it's even on both sides. So greater than that is going to equal 2.5%. And then that's my final answer. Looking at number 4, it says, at a New Age Information Corporation, the ages of all new employees hired during the last 5 years are normally distributed. Within this curve, 95% of the ages centered about the mean are between 24.6 and 37.4 years. Find the mean age and the standard deviation of the data. Okay, once again, I'm going to kind of try and sketch out the information I'm given here. So it's normally distributed, so I'm going to draw the normal model. The mean would go in the middle, but they didn't tell us the mean. they did tell us that 95% of the ages are centered between 24.6 and 37.4. Now, it's centered, and we're told that this is 95%, which means that the mean is falling directly in between these two values. So to find the mean, I can average them. So 24.6 plus 37.4 divided by 2, and that gives us a mean of 31. Now, finding the standard deviation can be a little bit trickier. Now, because we're told that it's within 95%, that means that 24.6 is 2 standard deviations below the mean, and 37.4 is 2 standard deviations above the mean. So that means that 2 standard deviations is going to be equal to 37.4 minus 31, which is 6.4. So 2 standard deviations is equal to 6.4. So to figure out what 1 standard deviation is, I would divide both sides by 2. So your standard deviation ends up equaling 3.2. So your standard deviation is 3.2, and your mean is 31. Looking at number 5, it says the amount of time Carlos plays video games in any given week is normally distributed. If Carlos plays video games an average of 15 hours per week with a standard deviation of 3, what is the probability of Carlos playing the video game between 15 and 18 hours a week? Again, I'm going to draw the normal model because we're told that it's normally distributed. The mean they gave us is 15, and the standard deviation is 3. So if I go up, that would give me 18. If I go down, that would give me 12. I'm actually going to stop here and not fill any more out, and that's okay. I know that within 1 standard deviation is 68%. And the reason why I stopped is because I'm looking for the probability that Carlos plays in between 15 and 18 hours a week. So I'm really looking for this area right here. And I already have my values, so I don't really need to keep going. Now, again, within 1 standard deviation is 68%. Since it's the middle, and the mean's right in the middle, and everything is even on both sides, I can take that 68 divide it in half and end up with 34%. So I know that this area is 34% and this area is 34%. So the probability that he plays in between 15 and 18 hours is 34%. I'm going to stop this video right here and do the last 3 examples in a different video. The last 3 examples, we won't be exactly 1, 2, or 3 standard deviations from the mean, so we won't actually be able to use the empirical rule. So I'm going to stop here, but I will finish up these examples in another video. Thanks, guys.